Hey, welcome to the third section of the course, Linear Regression. In this section, we'll begin by introducing linear regression with an example. Next, we'll use Scikit-learn. Post that, we'll learn about the three variants of the main model, lasso, ridge, and elastic net. At the end, we'll learn about the regression types. Now we move on to the first video of this section, linear model with an example. In this video, we're going to first understand what is a linear regression with the help of an example. A linear model is based on the assumption that it's possible to approximate the output values through a regression process based on this rule. In other words, the strong assumption is that our dataset and all the other unknown points lie on a hyperplane, and the maximum error is proportional to both the training quality and the adaptability of the original dataset. Let's consider a small dataset built by adding some uniform noise to the points belonging to a segment bounded between -6 and 6. The original equation is y equals x plus 2 plus n, where n is a noise term. In the figure, there's a plot with a candidate regression function. As we're working on a plane, the regressor we're looking for is a function of only two parameters. In order to fit our model, we must find the best parameters, and to do that we choose an ordinary least squares approach. This is a loss function to minimize. With an analytic approach, in order to find the global minimum, we must impose them. So, for simplicity, it accepts a vector containing both variables. Let's look at the coding for getting the equation now. As usual, we first import numpy. Then we define the loss. This is the loss function that we discussed earlier. Next, we define the gradient. Then we define the show dataset and add this code. We have to add matplotlib too. Running this, we get our plot of candidate regression function that we saw earlier. The optimization problem can now be solved using scipy as shown here. We've imported minimize. Running this gives us this output. As expected, the regression denoised our dataset, rebuilding the original equation, y equals to x plus 2.